In this video, we're going to talk about Littlewood's rule. Littlewood's rule is one of the most basic and useful results in revenue management optimization, and it's really the place to start. If you want to understand revenue management optimization models and you understand Littlewood's rule and really what's behind it, that's going to go a long way in your understanding of the more complex models. So let's talk about, before we get to the rule, let's think about revenue management, the role of revenue management and a revenue management analyst. So let's really understand the problem we're trying to solve before we get to how we're solving it. So let's assume that we have, take a very simple example. We're going to assume that we have a revenue management analyst. Let me choose my pen here. And we're going to make him green because he likes money, and he's happy because he's working in revenue management. And his job, let's assume he's working a flight. He's managing a flight. He's controlling the inventory, setting the fares. And his job is to sit behind a desk all day and take phone calls from prospective customers and either accept their request or reject their request for a seat given the fare that they're willing to pay. So let's say there's customers out there who are willing to pay $100, and we're going to call those the lower fare customers. And let's choose another color here, pink, for customers who are willing to pay more for that seat. Now the same seat, same product, but the two different customers willing to pay two different fares. Now let's look at what the revenue management's job here is. What is his role? Well, if he's got a few seats left on the plane, or let's say he's got one seat left, he's already sold all the rest of the seats, he's got one seat left, he wants to maximize the revenue that he can get for that remaining seat. So as he takes requests for that seat, he wants to choose the customer who is going to pay him the higher fare and reject the customer who is going to pay him the lower fare, right? So let's say these guys are really lined up the way I have them here. Let's say the $100 customer, or let's do it the other way around. Let's say the first person who calls him for the seat is the $200 customer. Well, the RM analyst knows there's only two types of customers out there because he's only got two fares in the market, $100 customers and $200 customers. If the $200 customer calls him and requests the seat, he's going to accept that request, sell the seat at $200, he's maximized revenue, and he's done. So that's simple. Well, what if the $200 guy doesn't call him? First, the $100 customer calls and requests that seat. Now the RM analyst has a decision to make. He can either accept that $100, accept it and know with certainty what his revenue will be, or he can turn down that customer's request in the hopes that the $200 customer will eventually arrive. And to do that, he really needs some way to predict, some forecast of demand that tells him how many customers are out there, what the likelihood is of this $200 customer materializing, right? So, because even with the best forecast of demand, we will never know for certainty. The RM analyst cannot know with certainty that a $200 customer will arrive, so he's got to apply some probability. So how do we do that? Well, we take the expected value. And that's the first term we're going to use here, the expected value. So if the expected value, so in our case, the expected value is simply going to be the fare, and we're going to call these guys, we're going to call this guy F high for fare high. We're going to call this guy FL for fare low. So we're going to say the expected value of fare, well, let's just do the expected value is the fare times the probability that that person arrives. And we're not going to specify the probability. This is just a nice way of saying I don't want to do it, so I'm going to put a dot there. Okay, so that means, so if I want to calculate the expected value of fare high, what I need to do is, I'm trying to move the screen here a little bit, it's not working, there we go. I take the fare, which in this case is $200, times the probability that that customer will materialize. In this case, let's say it's, we'll just pick a number, 0.2. So we have a $200 fare with a 0.2 probability that that fare will actually materialize. So that means the expected value of this higher fare customer is $40. So now the revenue management analyst has all the information he needs to make a revenue maximizing decision. If the lower fare customer shows up first and requests the seat, he can say, I can either get $100 with certainty. The expected value of this person is actually 1 because he's standing in front of the analyst, right? So $100 times 1 is $100. And he can say, I can either take that $100 or I can turn this customer away and wait for the high fare customer. But the high fare customer has a low probability of materializing, 0.2. So 0.2 times 200 is $40. So if he waits, he can only expect to get $40. Of course, he's either going to get 0 or 200 because either the customer is going to arrive or not. But his expected value, on average, he can expect to get $40. So in this case, the RM analyst is going to accept the $100 and sell that seat. And if high fare customers subsequently arrive, we say that's forecast error. If our forecast was better or we had more certainty, we would have held that seat. But it also goes to how aggressive this analyst wants to be in managing this flight. Having somebody on the plane is better than nobody when the flight leaves, and we don't want spoilage. We'll talk about spoilage at some point. Well, let's just change this probability just to drive home this idea. So let's say, I'm going to use a different color here. Now it's point, it's not working, so 0.8. With a 0.8 probability, I know that the higher fare customer will arrive if I save that seat. So now the higher fare, erase that, so the expected value of the higher fare customer is now 0.8 times 200, which is $160. $160. Sorry, let's do that. So that really makes sense. $160. Okay. So now again, if the low fare customer arrives first and requests the seat, the RM analyst will compare that $100 he can get with certainty to the expected value of holding the seat. In this case, if he holds that seat, he can expect on average to get $160. So in this case, he's going to reject this customer's request and protect that seat. We're going to use that term again in the next video. He's going to protect that seat. He's going to save that seat for the higher fare customer because based on his forecast of demand, he will be better off on average saving that seat than giving that seat to the low fare customer.